Welcome, everyone. We're beginning to see participants join us for this webinar. We'll get started in about 30 seconds as more participants join in to this PAVE Europe webinar series on testing autonomous solutions in highly automated vehicles. We'll get started right away. Welcome once again, everyone, to this webinar, part of a series of webinars by PAVE Europe. Today's topic is testing autonomous solutions in highly automated vehicles. Welcome to everyone who has joined this session. And of course, please know that this session is being recorded so that those who haven't been able to join, maybe the time zone doesn't fit for some people, and maybe the timing generally is not ideal for some people. And for those of you who have joined us, great. And those of you who are joining by recording, welcome as well. It's great to have you as part of our community at PAVE Europe. My name is Lukas Neckermann. I'm a co-founder and board observer at PAVE Europe. PAVE Europe is a not-for-profit Europe-wide organization that is focused on educating the public on the benefits of automated mobility throughout Europe. We're over 20 members strong, from Waymo to Oxa, Swiss Re, Mobilize, Smilytic, Score, PwC, Zeekr, many, many more. I encourage any viewer of this webinar to seek out PAVE Europe as a primary source of information. And also, if, like so many of you are involved in the automated vehicle ecosystem, then please do reach out to us to become a member organization of PAVE Europe. We have participants, we have viewers from across the academic, industry, regulatory spectrum, and we're going to try to get to as many of your questions. Many of you have already submitted questions before, but I would like to point out there is a Q&A button at the bottom of the Zoom window that you can also use to pose any questions as they come up, maybe as the webinar progresses. We will try to get to as many, or ideally all, of the questions that we receive from you. I am joined today by three highly distinguished guests, and I start with Professor Joachim Taiber. Joachim is Managing Director of the IAMTS, the International Alliance for Mobility Testing and Standardization. He has a long career that spans BMW and universities, and maybe this is saying too much or puts an age on us, Joachim, but we have known each other for over 25 years. So it's great to have you on this call with us today.
Thank you.
We're also joined by Professor Siddhartha Kaskir, who's Professor and Head of Verification and Validation at the University of Warwick. Thank you for joining us, Siddhartha. Of course, you are a distinguished researcher, and your research is also very, very hands-on as well, and I can't wait to get your inputs today.
Thank you for the very kind words, Lucas. Looking forward to it.
And we have Rudolf Gerlach, Manager for Global Regulations and Business Development at TÜV Rheinland's Type Approval Technology Center. TÜV Rheinland is, of course, a co-founding organization of PAVE Europe. So I'm very, very pleased to have you here on this panel as well, Rudolf.
Hello, thank you very much for the introduction, and a good day to everyone.
Great, let's get started. Joachim, I'll start with you. Let me start with an easy one. How does IAMTS work?
So yeah, IAMTS is a global community of experts, and we are recruited from industry, academia, and government. In total, more than 50 members, and we are engaged in developing collaboratively best practice information, methods, and tools to test and validate highly and fully automated ground vehicle systems. And our basic intent is to accelerate the definition of specifications and standards to make the operation of automated vehicle systems safer and more secure. So IAMTS is governed by a board. The board has 4 members, TÜV Association, which represents all the TÜVs, IEEE, SAE, and Qatar. And we are headquartered in Vienna in Austria. And we have chosen Austria carefully to be a neutral country because we are covering all regions in the world. So it was a specific request from our members to be headquartered in a neutral country. And our technical work is driven by a technical leadership committee. And the technical leadership committee directs the working groups and projects. And the daily operations are done by two managing directors. One is permanently in Vienna, my colleague Christian Lausmann, and I'm responsible for the international operations. So I'm traveling quite a bit, and I'm trying to be in close contact with our global members.
Fantastic. Thank you for that initial view, and we'll get into more details on what it is exactly that you do throughout the course of this webinar. Rudolf, from the perspective of TÜV Rheinland that many more people viewing will of course be familiar with, what are the most critical safety validation challenges that are specific to Europe in the context of highly automated vehicles that you're seeing today?
Yeah, if we are talking about the homologation process in Europe, but also about the processes which are ongoing in the states which do not have a homologation system, is that the regulation for the homologation are not available. Yeah, they are still under discussion, and what we are now doing is, if we have such project as a technical service, we have to do our own research, what to do to say or to validate that the systems are safe enough to be in traffic. I would say, thank God, at present we do not have really automated vehicles in Europe which are applying to get the approval to drive on the street. I think this is announced to 2025, and we try in Geneva under the UNECE umbrella to be ready with the regulation up to 2025.
Okay, thank you for that. I think there'll be different views on the thank goodness that we have or have not on that, and maybe we'll get to those as well. But let me get to Siddhartha as well. You head up verification and validation at the University of Warwick. I know that you're not purely academically focused. Your output is very, very tangible, as I mentioned. Can you tell us a little bit about your most recent work, Siddhartha?
Hi. Sorry, the lights just
working in a
switched off
blackout.
over here. Yes. So thank you, Lukas. And once again, thank you for the invitation. So WMG actually is an academic department within the University of Warwick in the UK, but it's very different to any other academic department that you might come across anywhere in the world. One of our ethos is actually that all the work that we do is either with or for industry. And we are very, very what we call as impact driven. So the research that we do, we don't stop at the research itself. We actually drive it either to a product with in partnership with industry, or to a policy or international standard in partnership with regulators and other international stakeholders. I'll give a few very quick examples of how research coming out of WMG has actually led into international impact for us. So if you look at the latest EU ADS Act, Automated Driving System Act, that was adopted by the EU Commission back in August of 2022, a lot of our research actually went into the whole scenario-based testing workflow that is actually part of the EU Commission's Act. So that's a direct pathway that we see, that research that happened within WMG and going its way, finding its way into an EU Act itself. The other quick one that I will share is something that we created in partnership with one of our partners called DeepenAI in the US. It's the Safety Pool Scenario Database, which is the world's largest public store of scenarios, which is actually underpinned by the philosophy that safety for automated driving system has to be pre-competitive. And I think it's one of the things that is testimony to a lot of the work that we do. We've got over 400 organizations now enrolled on Safety Pool who are using that as part of the scenario-based testing work.
That's such an important part of the puzzle, no doubt about it, because we can get to pool of insurance data, we can get a pool of crash data, but we don't have pools of incident data necessarily until you started collecting some of those scenarios as well. But beyond all of your work with WMG, you also have some news to share with us today that as it relates to PAVE Europe.
Yeah, thank you, Lucas. Yeah, we are absolutely excited and honored that we've been commissioned by the Department for Transport in the UK and the Department of Business and Trade to set up what is now being called as PAVE UK under the aegis of PAVE Europe. So the whole focus of PAVE UK is to actually embody the ethos of PAVE and PAVE Europe and actually take a more UK approach to addressing how we can actually bring in the conversations around automated vehicle education in a UK context. It's really important for us in the UK, and I think some of you would be aware of the fact that there has been the big automated vehicles bill in the UK recently, and we'll talk about that a bit later. So from a UK perspective, AV education is a big thing for us right now, and that's why we are investing dedicated just on that itself. So at WMG, we are honored to lead that, and you'll hear a lot more from us in the upcoming weeks and months.
No doubt about that whatsoever, and I can't wait for PAVE Europe to collaborate with you and the team at WMG for to help create content and materials for PAVE UK as well, extending, of course, the network of PAVE from North America, Europe, and the UK as well. So let's get right into today's topic. Remember, our perspectives that we share here today will be a little bit more European in nature, but clearly the learnings from today's webinar will be completely global in nature. Now, we've been testing and validating autonomous mobility for quite a while, pretty much the last decade or so. There have been some 50 different projects or more in Europe. Mostly these projects have been with 2, 3, maybe 5 or 10 vehicles, 15 vehicles max. Many of these vehicles have been supplied, for example, by EasyMile, another PAVE Europe founding member, I should add. Some have been legacy Navias. There's been a wave of custom-built vehicles, passenger vehicles, I should say, anything from 4 seats to about 10 or 12 seats. We've even got some, more recently, we've got some full-size buses trials, as we've seen from Adastec and on Carson hardware. We've also had some passenger cars that have been tested in various incidents and scenarios, Toyotas, Fords. If we look across the pond to the US, of course, we all know Chrysler minivans have been used. More recently, Waymo, using Jaguar, and now having signed a deal with Zeekr. Now, there are a lot of reasons why tech stack providers will choose to work with a certain hardware supplier, and a big reason is, of course, there needs to be an exchange of data. There needs to be a really close connection between the tech stack and the manufacturer and what the vehicle how the vehicle reacts on the one hand, but also how the vehicle feeds back. The OEM needs to share relevant data at all times, and some OEMs have been more forthcoming on this, which is the reason they've been chosen. On the other hand, I've heard from some providers that there's a certain reluctance on sharing enough data to make these pilots and future rollouts as successful as they possibly could be. Maybe that's even limiting progress slightly. First of all, any thoughts on this and the interaction between the OEMs and the tech stack providers? Maybe I'll go to you first, Siddhartha.
Sorry, yeah, I'm here. I think one of the things that we've noticed over the last few years is the fact that there has been a big reality check in terms of automated vehicle deployment. So yes, we've had quite a few of these small deployments in Europe, but I think it's over the last, especially over the last 3 years, we've seen that people have understood that it's not that easy, and we need to take a few steps back. We need to be a bit more humble in this space. And the other thing that we've also noticed is it's now become even more important to have a very strong commercial use case. You can't afford to go automated driving as an R&D pet project. You can't do it. You have to have a commercial use case for this, and you're seeing some very niche commercial use cases now coming across in the US, but also now in Europe. And I think that's where I see the industry maturing a bit more commercially mature, a bit more technologically mature, and now a bit more regulatory mature also.
So, and in some cases, it's 2 steps forward, 1 step back as we reevaluate certain things. Joachim, I'm looking to you now because you, of course, are sometimes largely, when you're not on a plane, based in the US, or at least have a good view of the US environment. So tell me how the cruise incident will impact the US approach and testing going forward.
You know, the key issue in the US, which is maybe different from the approach that I've seen in Europe or in Asia, is that the US is extremely driven by competition. So that means that in the case of cruise, I think we are discovering that we need a more collaborative approach. Although in the case of cruise, the big dispute was the interaction between first responders and OEM. And you cannot solve the problem if there's only a bidirectional communication between one OEM and a public authority. It needs to be a multi-stakeholder communication. And that means that you need to agree on common patterns, like you mentioned Siddhartha's work on a scenario database, right? So we need to agree on standardized scenarios that all the OEMs understand and want to acknowledge. So I think this approach to share more information to avoid the risk that then there is a heavy regulation coming from the government, that kind of mindset change is, I think, coming to fruition in the US. And so I'm hopeful that there's more willingness now to share.
So it's not just the sharing between the tech stack provider and the OEM. It's also the sharing with the regulators. It's the sharing with
the regulator.
First responders.
First responders is important, but also let's think about vulnerable road users. So, for example, scooters, bicycle drivers, even people that have a smartphone in the pocket. So there needs to be some form of standardized communication, mutual awareness, and understanding the patterns. And it also includes the infrastructure providers that have sensors. And so we need to bring also the V2X technology into this play.
Right, great point on the vulnerable road users as well. Rudolf, let me ask you quickly as well on this. Will that impact Europe or tests going on in Europe at all, in your view?
Yeah, I think it's a completely different scenario. If you're doing this in the US or you're doing it in Europe. In Europe, we have the homologation system, and you need an homologation for your vehicle. And for this homologation requirements, we trust on the UNECE regulations in Europe. And under the UNECE, there are since 2018, I think, 2 working groups working on validation methods, but also on the functional requirements. And what they established is a new assessment test method procedure, which is a completely new idea to homologate such vehicles. And this based on first an audit of the company. If the company is able to develop, produce, and bring on the market such vehicles, then the next step is that the functional safety and the safety of the intended functionality of the systems has to be approved. And then we will perform tests on test tracks. We will see what had the manufacturer simulated with the systems. And then at the last step, the vehicle will be tested on the road, like a driver will get a driving license, so the vehicle needs to get the license. And currently, we are not in a position to have these vehicles really on the road, which are level 5. We just made the first approval for level 3. We are now on the way for a level 4. But for me, a level 5 is far away from being present on the road. And what we have already on the roads are more or less level 2 vehicles with a safety driver in it. And this is something completely different if you look to the US market, where you really have the vehicle without safety driver.
And it really comes down, it's a great point, Rudolf, on the ODDs as well. And I'll come to Siddhartha on this one, just because I'm recalling an event you and we attended together, actually, in Dubai, where Cruise was presenting and launching its own activities in the Emirates. That was just before the incident in the US, of course. And it's one of these almost perfect ODDs for highly automated mobility. Dubai, you know, you've got wide streets, a clear problem, a congestion problem that needs to be solved. And there's so many of those. Not every ODD is, of course, perfect. And there's so many challenges in certain cities, certain environments, whether it's snow covered or whether it's, you know, heat or, but an environment such as this one is really a very, very good one. And I think, it's probably one of the reasons that Cruise had chosen that one. Would you concur with me that you know, we're going to take this, we're going to learn from it, and then, as I said earlier, two steps forward, one step back. Once again, we're going to accelerate broader scale operational rollouts in specific ODDs throughout 2024 and 25.
I would agree, but with a caveat. I think one of the things that has been shown over the last few months, especially with the incidents that have happened in the US, is collaboration and data sharing and transparency has become the most important thing in this industry right now. So people used to say collaboration is a good thing to have, say a few months or years back. Now it's essential for collaborations to happen. So for example, Rudolf was talking about the concept at the work that being done at UNEC. If you do not collaborate, you cannot create a regulation. It's not one country creating regulation at UNEC. It's all the people coming together. And similarly, if you look at the work that Waymo is doing, not the technical work, which is also quite good, but just the practices they have right now in opening up a lot of their safety processes, publishing a lot of the work that they're doing. And I see more and more of the developers actually taking that route forward, which essentially makes the average person on the street or average engineers feel a bit that ecosystem is a bit more transparent, how we are actually going to create the safety processes, the methodologies, the thresholds, the benchmarks. And I think that's what I see that would happen. What has happened, but we have to learn from it. There will be a lot more collaboration. There will be more transparency. We will start talking more about numbers in terms of engineering benchmarks. And I think we will see a bit more focused deployment in the future. So I think we cannot change what has happened, but what is important is to learn from it and implement the lessons.
I'm so glad that you mentioned the topic of benchmarks as well, and I'll get to you on this briefly, Joachim, and then we'll come to Rudolf as well. Only because you know, developers have seen themselves as drivers or a replacement for the human drivers. But the question is, how much? What is the benchmark? What is the standard that we're setting? Is it 5x? Is it 10x better than a human driver? I think there's initial evidence that's showing that the robot driver is a safer driver, perhaps even a smoother driver, more efficient driver than a human, and that the level of incidents are actually lower in most cases, or most ODDs that are currently being tested. I should be specific here. Than humans in the same ODD. But is it 1x or is it 5x? What is the standard? What is the benchmark that we're trying to set? Joachim, what are your thoughts on this?
You mean when you said 1x and 5x?
Yeah, how much better? How much better does the robot have to be than the human?
Yeah, so this is superhuman, right? So to speak. No, I think the important point at the moment is that when you are putting yourself in the shoes of a customer, of a user of a robotaxi, you expect at least the level of a human driver safety, if you put it, but you obviously would like to be even higher. You would be in a safer position. That means right now, I think most of the people that would go into a robotaxi would say, well, I don't trust this fully, right? So I'm not sure whether this can drive as safe as a human operated taxi. But if you enter the goal should be that we enter into a robotaxi that we say this is actually the safest way to go. But in order to get there, we need to change a little bit the rules. Having more sensors in the vehicle, I have basically an overkill of technology in the vehicle is maybe not the solution. And as Siddhartha said, we need to get into a sharing model. We have to share sensor information. We have to standardize interfaces. We have to leverage what the infrastructure knows about us to actually get to a superhuman, so to speak, safety level if we enter into an automated vehicle.
Okay. I'll get to Rudolf next, and Siddhartha, I know that you would like to comment on this as well, but I want to get back to one thing that Joachim said, and that's around trust. And one of the key missions of PAVE Europe is to help build trust in automated vehicle technology. And the country where we see actually has perhaps the greatest skepticism, or perhaps let's call it mistrust, of the technology is Germany. So does that automatically make it the most difficult country, Rudolf, for deployment? And if you can deploy in Germany, are all others easy after that, or are there just is that just one facet, one piece of the big puzzle? In the words of Frank Sinatra, if you can make it here, you can make it anywhere. What is that here?
So my experience from the regulatory work is that not Germany is the one which is the most critical one. If we look to the northern European states, they are more critical, much more critical than we are. Yeah? We have the industry where we are talking with since years about the systems. So we have already a good trust in these companies that they will produce safe vehicles and they will not bring on the market systems which are unsafe or might be unsafe. And if I'm talking with the ones in the northern part of Europe, they they always have problems to follow what will be developed by engineers, because they say if we have engineers which are developing the systems, we can be sure that these systems really will work for a human driver, for human people in the vehicles. So the problem is, you asked for how good has such a system to be. I would say it has to be on the same level as a careful human driver. And if this is the case, I would say they also in Germany will trust in these vehicles, and then they might also trust in the northern part. That's clearly a point. But I cannot say that we are the most critical one. The other ones are more critical, and they will see, let's look what's ongoing in Germany, and if they accept it, we can also try to.
Mm-hmm.
Arthur, you
I might just jump in here and make a point which is slightly maybe opposite to where Joachim and Rudolf are coming from. I think one of my very good collaborators, who's a social scientist, keeps taunting me and saying, you engineers should not be defining safety benchmarks. It's for the society to decide who
Yeah.
and how much safe they want the system as. And I think that's, even though he taunts me with that, but there's a lot of truth in that statement. We as engineers, we are nobody to say we are supposed to design a system which is 1x or 2x or 3x better. We need to engage with the society to understand what is their expectation. And I think PAVE as a platform would enable that to happen. PAVE Europe, PAVE UK, and PAVE in the US. But I think that's, from a safety perspective, we've got an engineering aspect to safety, but we've also got a big social science aspect to safety, which most of the times we tend to ignore in our conversations, which is what I would bring to this conversation, that safety as an acceptance thing is more of a social science construct than an engineering construct.
Yeah, and Siddhartha, because I'm right now in Minneapolis and I actually use the light rail, and I learned that using the light rail can be a safety risk because you can be attacked there, right? So that's a totally different dimension, that people actually are feeling more safer in a private company than in a public transit, and these are also aspects. I think the risks, what somebody considers as an acceptable risk, is definitely a social question, not only a technical question.
Super, thank you. I am going to jump to a pre-submitted question, something that we got by mail before the panel, and I would encourage anyone who has questions so far to please put those into the Q&A box at the bottom of your Zoom window, and we'll get to those questions in due course. So what is the main challenge in current simulation techniques, and what needs to be improved towards acceptance of virtual testing? Because we talked a lot about actual testing and on-the-road testing. Is virtual testing, broadly speaking, less accepted? Is it more accepted? Should it be on an equal plane? Because obviously a lot easier to deploy millions of miles or kilometers virtually than really. Joachim.
Yeah. So maybe what I can say, we are talking about so-called virtual validated, also tool chain validation. So that means we need to validate those virtual tools. To what degree can they actually replace the physical test? So that's the first thing that we need to figure out. And in general, the sheer amount of required physical testing would slow down the whole development speed. So we need virtual testing. The question is whether, when Rudolf talked about homologation a while ago, is whether the traditional homologation type approval process is relying heavily on physical testing at the moment. And there are, and at least at IMTS, we have many discussions at the moment, how can we reduce this and go to basically what quotation mark, what is a virtual homologation process. So I think the industry is definitely on this path, but there's still some way to go.
I might just jump.
Yeah, go ahead.
I'll just jump in on that one. I think as Joachim was saying, everybody will use virtual validation. So there's no question about that. That's not a question. That the biggest challenge that we see is how do you validate the virtual tool itself, the simulation platform. And I think that's the challenge that the industry is trying to answer. UNEC, the United Nations Economic Cooperation for Europe, is doing some work in terms of guiding principles on this. But that's the big million-dollar question that we need to answer as to how does a regulator or a type approval authority trust the simulation platform that a developer is using? That's the question that we need to answer.
Yeah, if I may step in, but we have in Europe already the ADS regulation for level 4, and this also contains the validation procedure for the simulation tools, and also the UNECE NATM based on several pillars. And one of the pillars, and I would say this is a huge pillar, is simulation. By the way, also in the past, we used simulation in homologation process because otherwise it would not be possible to get an approval for crash. Then say you cannot crash every derivative of a vehicle. Every crash test is more or less the worst case, and the worst case is determined by comparing different simulations. Yeah, and something similar is also here in place in these ideas, in this regulation. And of course, we also need simulation when we want to perform tests which are really close to an accident. Yeah, we do not want to kill our test inspector in this test, and they clearly necessary to use simulation.
And it
And-
increases the pool
maybe-
of incidents and scenarios. Yeah, go ahead.
One more question is maybe, or aspect to consider is also when it comes to bad weather, like fog, rain, snow. There can be easily limits on the simulation tools, and so that's partly also an active research topic. So that needs also to be put into consideration. How do we validate this when we go to weather conditions that are challenging?
Now, we've gathered a lot of data over the years on both simulated and in the real world, but also on the different levels. Now, of course, there are different regulatory frameworks by country, but also different frameworks for ADAS, different frameworks for teleoperations, which vary very significantly from the fully automated systems frameworks. Maybe a question to Rudolf. Would you see a convergence between the ADAS, the teleoperation, and the fully autonomous regulatory frameworks? Or are these doomed to be three completely different frameworks forevermore? This was a question that was submitted to us before the panel.
I think these are really two complete different things. Yeah? If I'm talking about teleoperation, we are not talking about autonomous driving. Yeah, this is a normal vehicle which is remote controlled. Yeah, and this is something completely different from an autonomous driving vehicle. And currently in the UN regulations, we are clearly separating level 3 from level 2 or level 2 plus, and we will have a new ADAS regulation called DCAS, where we have all the level 2 systems inside. So there's also a clear cut between the ADAS requirements and the requirements for ADS.
Here, okay. The UK has pressed ahead on the automated with the UK automated vehicle bill. Siddhartha, can you give us some insights on that? It basically sets the legal framework for the safe deployment of self-driving vehicles in Great Britain, and it was of course based on some work that's been done over the last several years by the law commissions of England and Wales, as well as Scotland. What does it achieve, and what's it missing?
I would start with what does it achieve. It's always good to start on a positive note, and then I'll talk about what's missing. I think it's a landmark moment for the UK and also for the AV ecosystem in general. So it's very easy to make a statement that the automated vehicles bill sets the legal framework, as you said. But the amount of work that has gone in to actually create that legal framework and the new entities that have been created, the actors that have been created. For example, the authorized self-driving entity, which we use ASD as in short, or the no user in charge or user in charge concepts that have been created, are fundamental from a liability perspective also. So when you're looking at a bill or looking at a governmental perspective towards a technology, their whole focus is how do we ensure that the society at large is safe when this technology is introduced. That's the whole goal. And the automated vehicle bill actually enables and sets out the legal framework that enables that to happen in terms of the roles for different actors. So for example, you might be an automated driving system stack developer, but you may not be the person who operates the robotaxi service. So you give your software service to another OEM, and the OEM gives the loans of the vehicles to a fleet operator. And so there are multiple roles that are involved now. And where does the liabilities begin and end? And that's what is being set by the automated vehicle bill that has been introduced in the House of Lords recently. And we hope very soon it becomes an act and the primary legislation is done. You asked about what is missing. Obviously, because automated vehicle bill is at a higher level of abstraction, what we call in the UK as primary legislation, it is missing some of the detailed engineering requirements. But that's by not an omission, but that's the nature of the beast. There is something called a secondary legislation that would happen after this becomes an act that would provide the more wider guidance on what is the engineering requirements. And to your earlier question, is it 1x, is it 2x or 3x safer than a human-driven vehicle? So that's what we'll do at a later stage. So it was hard enough to do the first one, so we thought we'll do it a bit later.
Very good. And what you do highlight is, of course, all of the different layers in there, again, from the tech provider, tech stack provider, the OEM or the integrator, the fleet management, even the connectivity provider up to and including right through potentially the front end, the mobile services or the mobility services provider that may be using the fleets of highly automated vehicles that were developed and put together by others. So that shows really how large that ecosystem is. It's something that we've always strived to do at PAVE Europe, to reflect the entire ecosystem, and on top of that value chain, if you will, of course, to have the testing, standardization, insurance organizations, and then of course have the public sector advisory council, as well as the Academic Advisory Council, all of which is part of PAVE Europe, where I'll once again suggest to anyone who's not yet looked into becoming a member of PAVE Europe to do so. Let me take a question that has been submitted, and I'll leave it to the three of you to duke it out who addresses it. There are standards and norms to certify safety already today. What about ISO 26262 to develop and assess functional safety of a system, and requiring safety critical embedded systems from ADS providers to ensure fail safe? That's the question that's been submitted. Who wants to?
Yeah, I can jump in because that is something which we already have in the homologation of systems with complex electronic functions. Since years, since ABS, I would say. And if we are looking to what we did into Rheinland for the approval of the first level 3 system, it really ISO 26262 SOTIFs, these are the basis of the investigation we did. And this is also one major pillar of the multi-pillar approach developed under the UNECE umbrella. It consists from simulation, track testing, real-world testing, in-service monitoring, but the basis is the audit assessment you have to do according to the ISO standard for functional safety and safety of the internal functionality.
And just to complement Rudolf's comment, I think sometimes when we introduce new technology, we have this fear that everything that we've done previously should be thrown into the dustbin and we start new. That's not the case. And I think this is precisely that's coming over here, that 26262 is still very valid, and it will be used, and it's part of all the conversations that are happening right now. What is being added on top of 26262 is things that 26262 doesn't cater to, things like SOTIF, that ISO 21448 about safety of the intended functionality that Rudolf mentioned. But more recently, there's another one that is being worked on right now, ISO TS 5083, which is purposely being focused on safety of automated driving systems. The concepts of operational design domain, concepts of scenario-based testing are being incorporated within that standard. So it's not like you have one golden standard that you can use to prove that automated driving systems are safe. You have to use a suite of standards. And to me, and to a larger section of this industry, ISO 26262 is kind of the foundational standard on which you build on your processes.
And I also want to throw here in something from the functional safety perspective, that we should also not only think about this one object that we, the vehicle that needs to be functional safe, we need also to look at multiple objects that move against each other. So swarm testing, so to speak. Yeah? So how do I validate the functional safety of a set of objects, not only of one object? And what we are doing at IMTS is we are working at the moment on testbed certification. We call it cyber physical testbed certification, where we are looking at these aspects. Also, how is swarm testing handled, and how do we validate the functional safety of that? So I just wanted to add this so that we're not misguided to just look at one vehicle.
Right. Thank you for the answer to that question from our audience today. I do want to take a step beyond testing as well, because at some point we will be rolling out swarms. Joachim, you used the term fleets, large fleets of highly automated, fully autonomous vehicles across Europe, across the world, and we'll continue to have that trust discussion. We'll continue to have that validation discussion, because the vehicles will continue to be updated. There will be surely safety and security threats. There will be cybersecurity questions that arise. How do we ensure, and who ensures, that we have a continual, independent, transparent, trustworthy audit and assurance of vehicles that have been deployed in such a way? And I'll start with Rudolf on this one.
Yeah, thank you. We already installed 2 regulations for that on the UNECE umbrella, which are also already in force for new types of vehicles in Europe, and will be in force for every new vehicle registered from July next year. This is regulation 155 on cybersecurity and 156 on software updates. The first one, I would say, is something which is clearly something which starts with the development, will go on with the production of the vehicle, and then the vehicle manufacturer has also to ensure over the whole lifespan of a vehicle that the vehicle will be safe. And this you can only reach if you regularly update it. And there was a need for the second regulation 156 for the update processes, which also clearly describes what has to be done in case of updates. The problem is that these are regulations for type approval of the vehicle. The vehicles already on the market are under completely different legal umbrella. This is the registration law, which is not harmonized, in the EU, so that you will have these problems taking care for the different national registration regulations in every country in Europe. And this is something where we also in Germany spent quite some time on to start a process to suggest a common way how to deal with the software updates. We already defined the 5 different categories of updates, and how to deal with these updates. And this is something we will propose now also for the European Forum, so that we can integrate it in the European, hopefully in the European approval process. But as I said, the biggest problem is that this is not harmonized within Europe, and of course not in the rest of the world.
And we have a work group on this for looking at over the life cycle of the vehicle and how to deal with updates. And as Rudolf said, this is not harmonized in the EU. And one of the key questions is also how often are you doing these checks? Because you basically, the fleet operator has to take the responsibility to make sure that the vehicle is all the time in compliance. And for that, if a sensor is deteriorating or a software update would get the vehicle out of compliance, that's a problem, and that needs to be regularly checked. And there are different approaches to that.
And I think lastly on this, I think that there are two aspects to this big question. One is the more of the data question and the data sharing question, and the other one is more around the process as to how you go about doing what we call as in the regulatory world in-service monitoring aspects. So I think on the data side, while people might think it's a much easier problem to solve, you get 10 engineers in the room, you get 20 solutions for how to put data together. So it's a much bigger challenge that people appreciate, but that needs to be sorted. So some of the work that has happened right now, which is more of a guideline text, not yet regulation in the UNEC world, is this: what type of information should you be sharing? We're still not talking about formats. We're still not talking about the methodology of storing that information. We're just talking about what kind of information needs to be stored or shared. Once we sorted that one out, then we'll go into formats, and then we'll go into the processes side of things. So I think it's more of a crawl, walk, run approach right now, and rightly so, because as soon as you start putting mandates for one particular type of technology, then you're either stifling innovation or giving somebody a commercial advantage, which also people do not want. So it has to be evidence driven, and I think that's what a crawl, walk, run approach would lead us to.
Yeah, and another thought maybe in terms of cooperative driving. So when we want to avoid that, let's say we're on a highway and we don't want that at the moment people are making a lane change or not going over a specific speed. The question is, where does this information come from? Is it from an overarching authority that provides this information? Is it self-protection of the different vehicles? There is still some lack of regulatory guidance on that, I think.
So I'm mindful of time. We have gone into various directions, and I think we've covered quite a lot of ground, very specifically on testing, regulation, validation of highly automated vehicle technology. But I do want to take a step back, maybe slightly less in the high-tech detail, and more on the benefits. PAVE Europe continues to focus on the benefits of what the technology brings to the mass public. We want to talk about the fact that there's an economic benefit, both at the micro and the macro level, that it creates a social benefit, greater accessibility of mobility for all. There's the potential to reduce congestion, especially when vehicles are shared and used across multiple purposes, and of course the fact that they are safe. So I'd like to ask each of you for some closing words. What should the public take away from today's session on testing highly automated vehicles? With respect to those benefits. Joachim.
I maybe can start. So I'm working right now quite intensively on the connection with sustainability. So how does autonomous driving help us to reach our sustainability goals? And I think if it's done properly, implemented properly, we should be able to save energy. We should also be able to automate certain processes like charging. There are some ways to, for example, work on inductive charging to save time. And also the other key question is with the electrification of the vehicles at the moment have a tendency to get bigger, to have more mass. And can we maybe through an intelligent autonomous driving system get to a better solution here to downsize the vehicles, still have safe operation? And so I think that the topic of safety, security, and sustainability needs to be looked at in context. And so I leave it at that.
Super, very important point.
I might go next. Yeah, on this, I think the big thing public should take away from today's session, but also a lot of the discussion around this space is they are the king or the queen of this space. They dictate how safe the technology needs to be. They dictate if they would like to use the technology or not. So they need to be part of the conversations. They need to demand to be part of the conversations. And as developers and engineers in this space, we need to bring them on this journey with us rather than just hand over the tech to them. Hey, there's a shiny piece of tech. It's supposed to be for your benefit, so just use it. I think it's bringing them as part of the journey and making them understand what safety is. And I think a big part, closing comment would be, we need to be better in communicating safety to public. We are very good in communicating, oh, I want 10 raised to minus 7. Nobody cares what 10 raised to minus 7 actually means when it comes to the average person on the street. So we need to be better in how do we communicate safety to the general public, and only then would the wider mass acceptance of this technology happen.
Thank you. That's a great message. Firstly, to the mass public who may be watching, and also to the community who is developing on what we should focus on in terms of our communication. Rudolf, I'll leave you the last word.
I will make it short. The aim of the EU is to bring the number of victims until 2050 in traffic to 0. And the only way is to reach this target seems to be to kick out the driver of the vehicle, because he is today and more than 90% the reason for the accident and the victims. And we as technical service will do our best that vehicles will be on the market only if they are really safe as a human driver. And these vehicles will then also accept all the traffic regulations which are not respected by the human drivers. And this will make our life much safer.
Very, very powerful message. And with that, I will close today's panel and our webinar with a big, big thank you to Siddhartha, to Joachim, to Rudolf for joining today, for sharing your insights. There are still some questions that are beginning to roll in. Please do feel free to submit them either to us at PAVE Europe or to the panelists. I'm sure we will find answers. And please make sure to follow PAVE Europe on LinkedIn and other channels so that you can get advanced information of future webinars such as this one. Thank you for your participation. Thank you for listening and joining us today. And we look forward to having you join us at the next PAVE and PAVE Europe webinars. Thank you so much. Have a great day.